All right, so if you guys read your message, I sent you guys a rubric and the answer key for lab work 12. Just now. Since you guys are here, let me explain to you guys what my intentions are. Here's the rubric. So the what we know is total of 4 points. Work on understanding on the left side is 4 points. And then your scan is 2 points. Okay? So for the what we know, since we're doing compound interest, that means we need to know both equations. We need to explain both equations. So the what we know, if you did not explain both equations, you lost some points. Fair? Oh, is right. So in here, I also explained some examples of n, right? So in other words, when we do compound interest, all of those problems should have the same exact what we knows. Shouldn't be different. Should be the same. Okay? That's the reason why you would put both of them in there. And then identify what is given, solve what is the question asking for, right? So if you have all of this, it's a 4 out of 4. If you don't, if you're missing 1 or 2 things, 3 out of 4. If you're missing more than a couple of things, 1 out of 4. If you don't put down any what we know, 0 out of 4. Okay? Working understanding. As I said, identify what is given. I identified what was given. Right? I selected the equation we're going to use because this is based on compounded contiguously. Plugged it in, solved. There's my answer. If you have everything here, 4 out of 4. If 1 or 2 things are missing, 3 out of 4. Number 3. And then if there's a whole bunch of things missing, 1 out of 4. And if you wrote the question and then the answer, obviously 0 out of 4. The last 2 points is based on your scan. If your scan is good, there's no spirals in it, it's not blurry, 2 out of 2. Most of the time I give you guys 2 out of 2s. It's only if like it's really blurry. I see a thumbprint in there, or a thumb in there, or like spirals in there. That's the only reason why I would go 1 out of 2. But other than that, I'm pretty lenient on that part. Yes? No, we can't put stuff from the problem into the what we know. Not the other way around. Okay? Come on. Respond. Come on. Respond. Wow. This thing does not want to respond. Let's try again. There we go. It responded. No, you guys are good. You guys are good. I'm just doing it for the camera. All right. So just reply to the email to let me know what you think you deserve. And then let's talk about today. So today, I start on page 1. Don't lie to yourself. Huh? So, if you guys notice that this page is all the rules that we've learned so far in logarithms, right? We learned how to convert exponent form into log form. We had a bunch of rules, and we talked about opposite operations as well, right? The product quotient power rule, and then also the change of base. Agreed? So essentially, I don't really need to teach today, because you guys have all the tools that you guys need. There's really only 1 or 2 things that I want to show today. But let's go through some problems. So let's take a look at that problem right there. There's 2 different ways of doing this problem. What's one? How? How? Oh, okay. So one you guys can do is getting it to the same base. Yes, anytime we solve, we're solving for x, but since I can write 125 as a base of 5, then I could do that. So what's my equation here? Are we okay there? Do you have a second way that we could do this? Because this is actually something that you actually have to know in order to do it, right? Anybody have a second way? No? Huh? Here, I'm just going to put the other way onto the side so you guys know. You could do it. Hey, you shrink. You move up here. That's the other way you could do it. However, with that, you're probably going to also need, do you? You're going to need this as well. I keep on getting that G in there. Get it out of here. So you'll need those two rules for the other method. I'll let you guys try it on your own. Is that fair? This way you guys can try a different method. Is that okay? Now, again, it all depends on how your brain thinks. But since she was mentioning that we can get the base the same, what should your question be next? What if we can't get the base the same? Right? If that 125 was like a 134, then what do we do? So let's say I got, right? If I got that, the bases are, I can't get the bases the same, what can I do? So I want to show you guys this. This is really the only lesson today. That's the only lesson today. Use log or ln. Use the common log or the natural log. If I can't get the bases the same, and if I take the ln of one side, I got to take the natural log of the other side. You can try, but I don't know why you would. What rule do I have that is exposed here? What rule can we use here? Huh? What is that again? Rule of 10? No. What rule do we have that involves the power rule? Isn't that right? The power rule? Does that make sense? And guys, just so you guys know, if I use log, I would have got that instead. Oops, forgot the one. The one disappeared. Sorry. Make sense? The only reason why I don't use log, I like ln, because I don't want the g to interfere with my denominator. That's all it is. Keep it cleaner. Are we okay there? Remember what I put here means the second method, right? Bless you, and I want you to try it on your own. Over here, same thing. I can go in exponent form, but then I'm going to need, hey, I'm going to need the change of base. So I want you to try that other way as well. Okay? I want you guys to try it that way as well. Are we okay there? Maybe? Did you want to do it right now? Or do you want me to continue on? I'd rather that you did it on your own. So, number one, guys, just so you guys know, the reason why, remember I said today I really don't have to teach much. Because I gave you all the tools already. Right? The question is, what tool are you going to use? That's all it is. You have the tool. I don't have to teach much today because I already gave you the tools. So let's try another example. How would you do that problem? Huh? You need that? So she's saying convert from log form to exponent form. Try it. Go. How good are we going converting from log form to exponent form or exponent form to log form? Try it. See what we get. Do it. See what we get. The other class was discombobulated. You're not sure if you got the right answer? Why? That's the right answer. If you're confident in your converting to exponent form or log form, then your answer is going to be right. The question is, should I check the answer or not? And why would I check the answer or not? No. No. Are we okay here? Now, I just mentioned that we should check. Why do we need to check? No. Nope. Can you guys tell me what the domain is? What's the domain of log? A log function? It's in your notes. What's the domain of a log function? Zero to infinity. So it says 0 to infinity, not including 0. What that means is that I cannot take the log of 0 or a negative number. Does that make sense? So the only reason I'm checking is to make sure I'm not forced to take the log of a negative number. That's it. Now, if the answer was a 3, I would have to reject it. Because 3 minus 4 is negative 1. I can't take the log of negative 1. Period. If the answer was 4, I'll have to reject it. What's another way of doing this? I want you to see if you guys can use this to make it happen. Are we okay? Do we know how that works? It's opposite operations. If the bases are the same, then they cancel each other out. But this is also the rule that we use. Here, I'll talk about this. This is also the rule that we would use because the base is a 2. Then I take 2, raise it to the power, and I will have left that as well. So it's that rule that converts it from log form to exponent form. Okay? Yeah? I want to see where you guys go with this. I want to see where you guys go with this. Gesundheit. Mm-hmm. Plus that, yeah. Mm. You can't do that. No. Mm-mm. Stuck? You can't do that. You can't do that. No, he's not right. Nope. Mm-hmm. Mm-hmm. She's right. Okay. First off, if I was in your seats, because there's a couple ways of doing it. You're doing it a totally different way, which I'm good with. I'm good with. I know exactly that is one way that I do teach it. But if I didn't know what to do, wouldn't you guys get all the logs together? You can get the logs on the same side, right? I'd be like, hey, I got log base 4, log base 4. Let me shift it all to the same side. Would that be appropriate? Seems logical to me. Dog poop. Scoop over here. Branches over here. Dog poop over here. Branches over here. Natural thing to do, yeah? Okay. What rule do we have right here? What rule do we have that would subtract 2 logs? Quotient rule. No way. That too. She needed her input. She needed an input. She put her input in. Okay, so what's the left side going to equal to? Right? What do I do now? How? Very carefully. Very, very carefully. How about with that? Do you think we should convert it to exponent form? Yes or no? That's the exponent form. The base moves to the other side. That's the base, right? How would you solve that? You can't x by itself. Solve for x. How? You can get common denominator. This is a very, very tough session, guys. And the only reason why it's tough is because you have to actually remember the rules and where to apply it. That's the tough part. Don't worry, I'm going to tell you what, I'm going to ask you guys what to do something for me on Thursday at the end of class. And if you guys do that, I do believe that this lesson will become a lot easier. If you decide not to do it, it might not become easier. Something simple. Don't worry. So what's another way of doing this problem? Has something to do that one. Has something to do that one. That one. What should I replace 1 with? Huh? No. What basis do my logs currently have? Okay. So what should the 1 become? Log base 4 of 4. So I'm replacing the 1 as this, because log base 4 of 4 is 1. Agreed? What rule do I have on the right side of the equation? Starts with a P. Product rule. Yes, product rule. Periodic rule. Hey, you shrink. So this is going to equal to let's see if you guys get this part. Do you guys understand that? How I did that? Are we okay? Questions? If you guys noticed, I plotted all the rules as I went, right? This is the tool I'm using. Do we have questions so far? Nothing? Everything's easy so far? Is it hard? In terms of like recalling. Yeah. That part is the tough part. I agree. No. It's a very common question. That's why I answer so quickly. No. There's no reference sheets. It really is just doing it enough. Yeah. All right. Here's one on your own. Ready? Good luck. Are you singing Ring Around the Rosie? What's wrong with you, boy? Do we know where to start? I see one bubble of a yes. Do we? I see one bubble of a no. Okay, let me ask you this. Well, number one, if you're trying to convert this to log form, don't. You won't be able to. Now, let me ask you this. Can we get the basis to be the same? Have we asked that question before today? Earlier today? Yes. Which was example number 2, yes? So maybe we should look at example 2 to give us a clue of where to start. Now, if you guys notice that a lot of these problems, it is about starting, right? But we still have to recall those rules that we need to use to get to the next step. And what we do with one problem does not necessarily mean that it's going to work for another problem. This is the problem with free will. Each problem is slightly different. However, example 2 that we did today will help us start this problem. ln or log, your choice. Go. Did you forget what example 2 was? There's example 1 on top. Example 2 is right underneath that. Yep. Got it? Like, sure, of course I do. Tell me when you have an answer. Not yet? Are we stuck? Already? We just started the problem. We're stuck. What rule do we have that talks about exponents? A power rule. Maybe we should do that. No, please don't tell me.
No.
Don't ask what the power rule is.
I know what the power
Okay.
rule is.
You should put parentheses around your binomials. He knows the word. He understands the definition of binomial? Oh my goodness. Goodness gracious. Great balls of fire. Yes. Put parentheses around your binomial. The other binomials. How we doing? Not so hot. I'm guessing everybody was able to do this. All right. Good start. We were able to start. That's good. Yeah. What the? No. So we talked about the power rule. So we're going to have to deal with the power rule. The power rule says this, right? That the exponent becomes the coefficient. Is that right? So am I guessing that this is usually where we get stuck? Can you type in ln of 3 for me? On.
ln of 3?
Yep. ln's over there. Enter. It's 1 point something, right?
Yeah.
Is that just a number?
Yes.
Okay. Do ln of 7. Is that just a number as well?
Yes.
So you're saying that ln of 3 is just a number. ln of 7 is just a number. Just a number. Agreed? Let's do a sidebar. Sidebar, sidebar, sidebar. So if I had what would you do? Distribute? Never heard of that before. We heard that before. Okay, cool. Agreed? We can just distribute that number, right? Okay, now let me ask you this. How do we go about from here now solving for x? Okay, remember what he just said. We're going to get all the x's by itself on one side and all the numbers to the other side by themselves. Is that right? Holy moly. Okay, okay. So we're able to do two-step equations. Yay! We're so good. All right, so what should we do here? Hey, we're going to distribute. Love it. So we're going to have 2x times the ln of 3 minus the ln of 3 equal to x times the ln of 7 minus the ln of 7. Did I misdo my distributing? We're good? Did you need me to do this? Is that what you needed? Make sense? Oh, I wrote this only as, hey, if ln of 3 is just a number and ln of 7 is just a number, because we were stuck on didn't know what to do. If it was just a number, like a 3, then what would we have done with that 3 to that binomial? We would distribute. Loss of words. Or too many words. Trying to come out all at once. It's like trying to fight to come out. Does that make sense? I'm not saying that ln of 3 is equal to 3. I'm just putting this as a sidebar so that we can know if it's just a number, we would distribute. If we would solve this type of problem, we would have just distributed. Right? Yeah, but it's 3 and 7. It's not that. So maybe I should have done this. Maybe I should have done that. Right? Instead of 3 and 7. But, okay, so I got this right here. So what should we do next? How do we solve for x again? Get all the x's to one side. I got two terms that have x's, right? One's on this side, one's on this side. Let me bring this one over. Okay. So like that. Yes? How do I bring this over to the other side? How do I bring this over to the other side? Cool? That makes sense? Okay. I'm sure that other people were confused as well, so it's not a bad question at all. Okay. On the left side, the bad news is that I can't subtract these two, can I? But what is in here? Which is called a what? He said x, which is called a what? Thank you. So I can take a GC of x out. leaving me with boom, shaka, laka. So that would be your exact answer. And instead of ln, you could have, but if it would have asked for an approximate answer, then you would use your calculator to type it in and see what the decimal value is. So there's no really way of using the choices to find your answer. Huh? You can try. I can't afford that. Any questions here? So if I'm right, everything today so far, besides getting to the same base, besides using ln or log, there's nothing else that we went through that wasn't review or was new, right? Everything was reviewed. So, any questions for me at this point in time? Again, the tough part is recalling. So here's what my suggestion is going to be. Gesundheit, or I should say salud, since I already said Gesundheit to you already.
Why did you choose to use ln again?
Here, I'll show you. See how like the ln right here is all like the numerator is the numerator, the denominator is the denominator. See how the g kind of dips down into my denominator? I'm trying to stay away from that. I don't need anybody's tail in my vision. That didn't come out right. So here's my suggestion. My suggestion is this. I don't care if you decide to write all these rules on a page of paper on your own. Not a bad idea. Or that when this gets posted, you can print out the first page, because this will be the first page of the notes today. Either way, I want you to print it out because it's not going to be on your exam. So what I'm going to ask you guys to do before your next class is this. Do 4.4 in your MLM and your lab work. In MLM, the good news is that you do a problem. If you use a sheet, do a similar problem. Do a similar question. Do a similar question. Do a similar question. I want you to do enough problems where, number one, you can go, I already know the rule to use. It is this rule. Even if you didn't know the name of the rule, you can at least write down what it meant. Does that make sense? Because some of these rules, we really don't have a name to it. Right? I want you to do enough so that you don't have to, number one, the recall doesn't become difficult anymore. And this way that you remember all the rules, so on the exam, you're not going to be like scrambling. Okay? So that's what I want you guys to try to do for the next class. And I want you to bring in problems that you find very difficult and not knowing where to go. That's what we'll do on your next class, is that we're going to talk about what problems you had an issue with. We're going to bring it up. We're going to talk about, as a class, what will we do? and see if you guys can practice those and write those out as well. Okay? Sure. I don't care. Like I've ever voted against taking pictures. Now, I would say this. We all want to be right the very first try. We all do. Sorry, life doesn't work that way. Right? So, the next best thing, I would tell you this. The next best thing is do a problem. Get it wrong. Get it wrong. And then fix it. They always said, make a decision, then make it right. If you're going to wait until the right decision, you're never going to make a decision. The worst thing you can do with these problems is to do nothing at all. If you sit there and just stare and saying, Chan's going to do this problem, well, guess what? Correct. That's exactly right. All right? Life does not work that way. You can't wait for Chan to make a decision. That'd be an awful idea. Awful idea. Okay? So, again, getting it right would be great, but this next best thing is actually doing it. Diving in. Making the mistake. Who cares? Right? It's not like an angel loses their wings because you made a mistake. And a body drops from the sky. Right? That's not going to happen. Watch, you guys make a mistake on what the So no other questions for me? All right, ladies and gentlemen, please have a wonderful, blessed day. Please be safe. Love you guys. See you guys next class. See you later.